We are putting Earth's ecosystems under more pressure each and every day. With an ever-growing population on an already overpopulated planet, we are reminded constantly of the consequences of our own actions. The more we learn about the environment, the more we realize how ill-equipped we are to manage it sustainably. Despite the widespread efforts of environmental experts to solve global environmental challenges, the Earth continues to plummet toward degeneration. Mother Nature has proven herself a powerful force. It's time that we harness her power. The University of Oklahoma Center for Restoration of Ecosystems and Watersheds works with Mother Nature, designing and implementing natural infrastructure to manage and restore ecosystems. We rely on the ecosystem's natural biogeochemistry and renewable energy to passively treat mine water. It's how we take contaminated water from this to this. According to the nonprofit American Rivers, Tar Creek is one of America's most endangered rivers. Within the Tri-State Mining District, mining in Ottawa County, Oklahoma supplied nearly half of the lead and zinc during both world wars. When mining operations were abandoned by 1970, underground mines filled with mine tailings and water were left behind. Metal-contaminated groundwater and runoff from toxic mine tailings discharged directly into Tar Creek. Tar Creek was declared irreversibly damaged in 1984 due to elevated levels of iron, zinc, lead, cadmium, and manganese. Crew has worked in catchments and around seeps throughout the Tri-State Mining District since 1997, working in conjunction with Mother Nature to address the severe contamination. The Mirror Ranch Passive Treatment System is composed of 10 process units in total, with 6 different types of treatment ponds split into 2 treatment trains. Since operation began in 2008, it has retained over 1 million pounds of iron, 44,000 pounds of zinc, 570 pounds of lead, and 94 pounds of cadmium. Underground mine water discharges from 3 seeps into the oxidation pond, where iron is oxidized and hydrolyzed to form oxyhydroxide precipitates. Using weirs, the water then makes its way into the surface flow wetlands, where these precipitates continue to settle. The waters then enter the vertical flow bioreactors, which retain lead, cadmium, and zinc as sulfides by promoting bacterial sulfate reduction and related processes. But these anaerobic processes greatly deplete dissolved oxygen. The re-aeration ponds rely on wind and solar power generation to restore oxygen to the water and strip any hydrogen sulfide and biochemical oxygen demand. The horizontal flow limestone beds serve as a polishing unit for zinc and manganese, and lastly, solids are settled in the final polishing pond. This unit acts as an ecological buffer, preparing water to be released back into the ecosystem. The research philosophy at the Center for Restoration of Ecosystems and Watersheds focuses on taking a holistic approach to environmental reclamation, restoration, and remediation. Using our understanding of ecosystem biogeochemistry and ecology to develop sustainable solutions to complex environmental challenges. Working together with Mother Nature, nothing is irreversible.